So it's super important that you're using your calculator effectively, otherwise in an exam you're just going to run out of time if you're trying to do everything the long way. So we're going to look at polyroots in this one. This question here, by the time you get down to the third or fourth step, it's asking you to solve a quadratic. And so once you've subbed in the first term of 5 and the common difference of 3, and do a little bit of algebraic manipulation, you end up at here. 0 equals 3n squared plus 7n minus 2000. If you try to complete the square or solve algebraically, it's going to take a really long time. So instead, we jump into our calculator, we press the number 1 to create a new document, number 1 here. We don't want to save our old document, so just arrow across and hit enter. And then we want to add a calculator in here. Now after this, usually you're going to press the menu. The menu is going to have a whole bunch of options. You're going to arrow down until you hit the algebra one. Polynomial tools is what you want. And then you want the real roots of a polynomial. Don't hit this one, I don't really like this one. Real roots of a polynomial. Okay, and then it's really simple, you just type in this. 3n squared plus 7n minus 2000. 3n squared plus 7n minus 2000, comma, and then the variable that you're using. I'm using the variable n here, so I press the letter n. Okay, when I do that, I'll get two answers, negative 27.01 and 24.67. Now, obviously, you need to reject one of these. The negative doesn't make sense in this case because we're adding up a bunch of terms. So make sure you write down what you've done, reject the negative, n equals 24.68, but that doesn't make sense because we want to calculate the number of terms required for the sum of the sequence to be greater than 1000. We can't have decimal number of things. We need to round up, therefore n equals 25. The 24th term is going to be less than 1000, the 25th term is going to be more than 1000. The sum of those is going to be more than 1000. Of course, you can work the other way here. You can type that into your calculator, type the original formula into your calculator, subbing in 25 for n, and you can see my answer is 1025. That sum is greater than 1000, so I think I'm on the right track.